Science Year 3 in the Family School Online, and the lesson today is on metabolic pathways. So last time in lesson 9, I was going to do both topics, fermentation and metabolic pathways, but we really ran out of time, and I didn't want to drop this concept. This is important information really to understand, and so I decided, okay, let's create a separate lesson and have that lesson here today. Okay. As a quick review, if you remember, in the previous lesson we watched 2 videos. One was a video of a couple of triathletes that were sprinting at the end of a triathlon, and as they crossed the line, they were gasping for air. Okay, so what we saw there in that sprint, and what you see whenever there's intense activity, intense exercise, without enough oxygen, the athletes could not breathe fast enough to bring oxygen, is that the body goes into lactic acid fermentation, and so it keeps producing ATP, even though it's just a little bit of ATP. It's not as much as it would do with oxygen, but it keeps producing ATP under fermentation conditions. But that can only last for so long, and after that, you are just gasping for air, really. And the other example that we saw was of a couple of people finishing a marathon and hitting the wall, okay? That was the case. That is a different case. In this case, the athletes were not sprinting. It wasn't that they ran out of oxygen or they stopped breathing. What happened was that they ran out of glucose to burn. And so the body started shutting down because it couldn't produce enough ATP to keep going. And so what we are going to do today is look at what are some of the different pathways or metabolic ways in which the body can continue producing ATP. Okay? So Anna, would you like to get us going on this part, on the academic concept 1, please? Okay.
Okay. All right. So I just finished the lesson, so hopefully the video. So we'll see how this goes. I guess I thought this video was really fascinating because it talks a lot about why I guess fats are really a good energy storage. It started out by talking how we get energy from the food that we eat, and that energy is ATP because it breaks down the acids and the glucose inside the food into ATP. It also talks about how we don't eat constantly, so we need a way to store food. And it talks about 3 main points that we use to store food, in glycogen, proteins, and fats. And then it goes through all 3 of those, and it talks about which are more efficient and things like that. In fats, they came to the conclusion that fats are the most efficient way to store foods and energy because, let's see, yeah, it's the most efficient way, and hold on a minute.
Well, let's see where we get to that point. Okay, I think over here. Keep going.
Okay. So fats, I think the most common type of fat that we store in our bodies is called triacylglyceride. I think that's how you pronounce it.
Yeah, it's triglyceride. Triglyceride.
Okay. This is made up of different groups of carbon and hydrogen and I think molecules, and they talked about how fats are more energy rich in molecules, so they contain a lot more electrons, and so they produce a lot more ATP. They also they don't react with other parts of the bodies, and they also don't have an other part or function in the body, so they're not needed in other parts, so they can be focused in on creating energy.
Mm-hmm. Yeah. What does it mean here that they are inert, that fats, lipids are inert? Do you remember what does that mean?
I think it means that they don't react with other things in the body.
Exactly. Good. Mm-hmm. Excellent. Mm-hmm. Yeah. What does it mean that they have no functional role?
To me, I kind of got that they aren't used for other main parts of the body, and they aren't needed for a lot of other places in the body, so the energy stored in them can be used mainly for energy, I guess.
That's right. That's absolutely correct. Good job. Yes. Mm-hmm. So the only part where I've seen lipids having a functional role is in the membranes. You know, when we were talking about the phospholipids, they are a slightly different type of lipid. Instead of having 3 chains, they have 2, okay? And they have a phosphoric group here joining the 2 chains. But that is the only one that they have a functional role. But the other lipids, like this, the triacylglyceride, it has the only reason they exist is to store energy. Okay. Mm-hmm. Okay. What does it mean here, the number 4?
Very hydrophobic. I guess they don't carry a lot of water, so they don't have to be weighed down by water. I think they went through like a math problem showing how much water they would contain if they could, and there was like a lot of weight, so it's very efficient because it doesn't have to carry a lot of water around.
That's right. So they are hydrophobic. That means that they cannot be dissolved in water. Okay. And if you think of that, you know, what happens when you put a drop of oil on water? Do they mix?
No.
They don't mix. Okay, so the oil is hydrophobic, meaning that it's completely separate from the water. And so when it is stored in the body, this molecule is stored without any water. Okay, there are cells, they are called adipocytes, so they are cells just for adipose tissues to store fat, all right? And they don't have any, you know, they basically have like a back wall or a vesicle that stores these molecules, and they don't carry any water, okay? Now, what happens when you put some sugar, like a tablespoon of sugar, in water?
I think it just dissolves.
It dissolves, that's right. So is sugar hydrophobic?
No.
No. The word that we use is hydrophilic, okay?
Oh, yeah,
hydrophilic. Okay. A friend of water, all right? Friendly to water, all right? And so the molecules of glucose, they need to be dissolved in water. And so that is one of the problems why the body, in order to carry glucose, to store glucose, it also needs to have about 3 or 4 times the weight of the glucose plus 3 or 4 times water. Okay, so it's a lot of water. The water is just for storage. In that case.
Wow.
Yeah. Okay. So here, let me see if we get to this part where they explain that in the thing. Let's see. Okay, all right. So here we have that for glycogen is a very big molecule of glucose. Okay, so it's basically chains of glucose molecules. Have you seen that, Maria, Anna? Mm-hmm.
Yeah, I think I saw one of those pictures on Wikipedia about that.
Mm-hmm.
The
Okay,
glycogen.
let me show you that one. Yes.
It's got like the protein in the middle, and then those little chains of glycose.
Yes. So here we have, see how big, and this says that a granule of glycogen could have about 30,000 glucose units.
Wow, that's a lot.
Okay, that is a lot. Just a little granule, okay, of glycogen. Okay, and see this is interesting in this article. Here it has even a picture. All right, and you see this is in a cell. All right, so we see the cell nucleus. Okay, and these areas with G, these are the glycogen granules.
Okay.
Okay, so you see how the granules are stored very close inside the cell, and they are close to the mitochondria. These M are mitochondria. Mm-hmm.
Oh, okay.
Okay. So the granules of glycogen are stored directly there, but the problem is that in order to store this glycogen, you need to have a lot of water also for storage. Okay. So if we have, let's go back to the video here. If we have, it says 1 gram of glycogen, you would need 3 grams of water for that. Okay. So that is a lot.
Mm-hmm.
Because then you are basically using 4 grams of body weight in order to have the same equivalent of what you would have for the fat. Okay, so fat is a lot more efficient for storage. Mm-hmm.
Yeah.
Do you remember towards the end of the video what she says about the amount of ATP that lipids can produce?
No, I don't think so.
Okay, I think that it wasn't in this video. Right? No, that's right. Okay, so what is the process for this fatty acid to convert into ATP? How does that happen?
I guess the insulin signals, and then the triglycerides, they break down into fatty acids, and then they're transported into the bloodstream, and then they go into the cells to be oxidated.
Mm-hmm.
Then I guess these go. Oh, go ahead.
So let me see, Anna. This thing. Okay, here in this sentence it says when blood sugar is low, decreased insulin levels signal the adipocytes to break down the triglycerides. Okay. So when do you think that happens when blood sugar is low?
Maybe when you're running out of energy.
Yeah, that could be. Mm-hmm. So if you haven't eaten for a while, okay,
mm-hmm.
or in the case that you are exercising and then the level of sugar in the blood it starts decreasing. Okay, so that could trigger this this signal. Okay, here Connor says you get dizzy or hypoglycemic. What is hypoglycemic? What would that be? Connor, would you like to comment on that?
What was the word?
Hypoglycemic. Let me unmute Connor and see if he can explain that. Okay, Connor, what do you know about hypoglycemia? You are unmuted. Okay, you need to unmute your microphone. There.
Hello?
Yes, hello. Yes, stand by,
this
Anna.
is his sister.
Okay.
This is his
Go
sister.
ahead,
My computer's not working, so me and him are sharing. So I put down hypoglycemic. And hypoglycemic is when your blood sugar drops, whether from like you're not eating or if you're kind of unhealthy, and I'm not really exactly sure what it is, but your blood sugar drops and it causes you to get dizzy and
yeah.
Yeah.
You probably have feel a little bit of that, or at least I have felt that when fasting. Okay, during fast Sundays, towards the end of the fast and everything, sometimes you feel that sensation, that feeling of being a little bit hypoglycemic. Okay, so the condition of hypoglycemia, though, when it's really bad, the problem is that for some reason the body doesn't process the signal of the decreased insulin in the blood to start breaking down the triglycerides. Okay, so that is when there is actually a problem in the condition. Okay, so we have that this is the trigger. This is an important trigger to start the process of fatty acid metabolism, okay? Because if that trigger is not working for whatever reason, then that could be problematic, okay? So we see that the fatty acids are broken down, they are separated, okay? The process is lipolysis, and then they are released into the bloodstream, okay? What does this next sentence mean, Anna?
I guess the fatty acids, they're transported to the mitochondria.
What does it mean that they are actively transported?
I guess kind of maybe a constant flow.
Okay. Okay. Remember when we were talking about the cell membrane? Okay, that we said that there are two types of transportation. One is active and the other is passive. All right. So what is an active transport? What would be the active transport?
I think I remember vaguely talking about that, but I can't remember exactly what that is.
Anyone else remembers what it means to actively transport through the membrane as opposed to passive transport? Okay. All right, Emmeline says passive transport moves things from lower concentration to higher concentration. That's right, okay? So passive transport is when the movement of these molecules happens just by diffusion, okay, passively, all right? Connor asked the question, metabolism? No. This is we are actually studying metabolism. Metabolism is the chain of reactions here. So active transport means that, do you remember, Anna, how in the cell membrane there were in some parts of the membrane little proteins embedded into the membrane?
Yeah.
Okay. Those proteins were specifically designed to bring things in or out of the cell. Okay. And in order for those proteins to work, they need ATP energy in order to make the reaction. And so they are in the cell membrane and also in the cell membrane and in the membrane of the mitochondria. Okay, there are proteins that are specifically designed to bring fatty acids through the membrane, but they need to use ATP. Okay, so in order to make energy, you have to spend some energy.
That's funny.
Yes, that's right. That's right. Okay, so the one part of expending energy here is for the active transport of the fatty acid into the mitochondria. Okay. All right.
Okay.
So what is next?
Yes, in the mitochondria process of beta oxidation, it kind of breaks down the fatty acid and it turns it into acetyl-CoA.
Mm-hmm. Yeah. Okay. So we have the fatty acids. Okay. There are these 3 chains of carbon, all right, and hydrogen. And then they get inside the mitochondria and they are broken down into acetyl-CoA. This is the picture of the molecule of acetyl-CoA. Okay. And the part of this acetyl-CoA that is kind of the functional group, let's call it, the part of the fatty acid that is added to it is this one here at the very end. Okay? So during the process of beta oxidation, what the body does is it breaks down the links here, the chains of carbon, okay, into 2 carbons, into just 2. All right. So, for example, if you have this palmitic fatty acid, it has 16 carbons, so it's going to break it 8 times into chains, very small chains of just 2 carbons, and through the process of beta oxidation, it adds this part to this whole molecule, and now this becomes the acetyl-CoA. Okay. Do you remember what? Okay, it makes sense. And look at this. I don't know if you can see this, but doesn't this look familiar? Okay, this looks kind of like the adenine. It looks kind of similar to the ATP molecule.
Oh yeah.
Okay, you have these rings. This one here is the ribose sugar. Here, in this case, you have 2 separate phosphate groups, all right? And then you have another chain. So this part is kind of similar to the ATP, you know? So you can see now how all these enzymes and things are basically made out of the same things, out of the same building blocks, really. It's really interesting, you know?
Yeah.
So, do you remember, Anna, when we were talking about cellular respiration, where was the acetyl-CoA used? What part of that process was the acetyl-CoA used in?
Wasn't it used in the citric acid cycle?
Excellent, that's right, yes. So in the acetyl-CoA is used in the citric acid cycle, okay? So after we break the pyruvate, it also forms acetyl-CoA. And then once you have acetyl-CoA, then the mitochondria can do the citric acid cycle and then do the electron transport chain. Okay?
Okay.
Yeah, so the cool thing is that when we get these chains of free fatty acids, we break them down, we make acetyl-CoA, and then what can happen? What do we do with the acetyl-CoA?
Isn't it turned into ATP, I guess?
That's right. Yeah. So we use the acetyl-CoA to do the same process of the citric acid cycle and the electron transport chain, okay, and produce ATP. You know, and here we have that a fatty acid of 16 carbons can produce how much ATP?
Looks like it says 106 ATP.
106. All right, and so
that's a lot of ATP.
A lot of ATP, yeah. Because remember how many carbons did glucose have? How many carbons were in the glucose molecule?
I can't remember.
So it's just 6. It was just a ring, you know, with 6 carbons and one sticking out. All right.
Oh, okay.
Okay. So we can see it here. Let me see if we see the yeah. Okay. In here you see the little pieces of glucose. We have 1, 2, 3, 4, 5, 6. Okay. You see that this is the glycogen, but it's made out of glucose. Okay, so each one of those has 6 carbons. So 6 carbons gave us how much ATP in cellular respiration?
Like, was that 32?
That's right, yes, 32, yeah. Okay, so 6 carbons, we get 32. 16 carbons in a fatty acid chain give us a lot more proportionally, doesn't it?
Yeah.
Okay. You know, because let's say if you have, 18 would be 3 times. You know, if you have three glucose molecules, that would be 18 carbon lengths. Okay. And that would be 32 times 3, 96. Okay, so 96 for 18, here we have 16, 106, you know?
Yeah.
So a lot more efficient there, okay? So, yeah, and on top, we have that, we learned, remember here in the video, that you can store a lot more of fatty acids than of glycogen in less space in the body. Okay.
Yeah, a lot more efficient.
Yeah. So very, very efficient way of processing the energy. Okay. And we have a lot of that in the store. The trick is for the body to continue breaking down the triglycerides and the fatty acids and not running out. Okay. So Anna, thank you very much. Is there anything else that you would like to add?
Not really.
Okay. So I have a question. To do this beta oxidation, to do the process here of fatty acid metabolism, do you still need oxygen?
Yes, I think so.
Yes. Why? Why would you still need oxygen?
I
Where
guess
was the oxygen used in the whole process? Hmm?
Isn't it in the electron transport chain you need to use oxygen?
That's right. Yes. So the final step in the electron transport chain, that is where you need the oxygen. And so if you don't have oxygen, you cannot do fatty acid metabolism, and you cannot do cellular respiration. Okay.
So kind of stuck
you know,
if you don't have oxygen.
yeah. So not a good thing. Okay. So don't hold your breath.
Yeah.
All right, excellent. Thank you, Maria. Thank you. Hey, Anna, thank you very, very much.
You're welcome.
All right, good job. Maria, would you like to take us through concept number 2?
Yeah, okay. So in this concept, it kind of tells us what athletes should do, like, because it's when athletes consume all their stores of glycogen in the muscle and liver cells, they hit the wall, which I don't think they actually hit a wall. They just kind of, the things in their bodies start to, like oxygen, they'll run out of oxygen, and carbohydrates, running out of glycogen, and they have some things that long distance athletes should do, or just any athletes, like eat lots of carbohydrates during exercise so that they don't run out of glycogen, like such as like dried fruits, bread, fruits, or yogurt, anything like that.
Mm-hmm.
And they want to, it's good to breathe in steady supply of oxygen, like have like in through your nose or out through your mouth. That helps as well, so that you don't go into fermentation. That wouldn't be very good. And
that's right.
breathing out carbon dioxide so it can produce during respiration. And a big thing is to drink water to so you don't get dehydrated, and so that your body will be able to transport substances in the heat. So, and consuming or eating electrolytes such as, like it says, salt, potassium, calcium, magnesium, so that you can maintain a balance that many proteins that in your cells need to function properly. So like it says, for example, that muscle contraction is all dependent upon the presence of calcium and like sodium and potassium. And when you don't have enough sufficient levels of these electrolytes, like important electrolytes, then your muscles will start to weaken, or contractions may occur to your muscles. And
have you ever had, Maria, have you ever had a Charlie horse?
Oh, what?
What we call a Charlie horse, okay? Connor says yes. Okay. Connor, would you like, come on, okay, open your mic, all right, and tell us how did you feel when you had a Charlie horse? Jen says that it's a cramp, okay? A Charlie horse or a cramp, all right? How do you feel? So Connor says, worst thing ever. All right, come on, unmute your mic and tell us how was your experience with a Charlie horse. Go on.
It's his sister again. Well, I'm probably embarrassing him because everybody thinks it's him. But when I do dance a lot, so I stretch a lot, and so one time I was stretching like my legs, and it just it happened to my calf, and it hurt so bad. And I was like, what is this pain? And I thought this is the end. It was one of those things where you stub your toe and it was awful.
Yeah. So the Charlie horse is an involuntary contraction of the whole muscle in the calf because it's deficient of one of these nutrients, all right? Usually it's a lack of potassium. Potassium is found in bananas, for your tip, okay? All right. So, but the muscle contracts, and it's like you have a lock on the muscle, and it hurts. It hurts like a mother. All right. So really bad.
Dairy in it, so I'm seeing that there's calcium. So, and I'm trying to take calcium supplements, but I don't drink or eat anything with dairy and milk in it. So.
Okay. So, yes, if you don't have dairy, you have to take calcium supplements, especially if you are a woman. Okay. So women need metabolize a lot more calcium through the mammary glands, and also because of the menstrual cycles. All right. So you actually need more iron and calcium in order to supplement those things. Okay. And if you are not taking any dairy products, milk and cheese and so on, you need to supplement those. Okay.
Yeah, I take a lot of for that.
Excellent. All right. So here, someone also mentioned that spinach has this nutrient. Mm-hmm. So Liberty asked, where does the name Charlie horse originate from? I have no idea. It's English. Okay. So Natasha says that she never had that happen. All right. So spinach, Josh says that spinach has more than twice the potassium. Says to try almond milk also. Mm-hmm. Yeah. So Jens also suggests pickle juice to stop cramping. And I tell you, that is actually very, very good to stop cramps. So I am, among other things, okay, a long-distance runner, okay? And so I like doing marathons and races. I've done also long-distance races like ultra running, 50-mile races, and 100K, which is 62 miles. That's my longest, all right? And you have to actually eat a lot during the race. And you have to take care that you are keeping very balanced in all these things. So all these things that I put in here are from personal experience, okay? Usually when I'm in one of these long-distance races, during the middle of the race, during each hour of the race, I have to take electrolytes, and I have to eat about 100 calories of carbohydrates, sugars, bread, anything, okay? And I tell you, it doesn't taste very good after a while. Everything kind of tastes tasty and yucky. And you have to continue drinking, all right, and make sure that all your body is working well. But at the middle of the race, one of the things that I like to do is to drink about a cup of pickle juice, okay? So we usually get a jar of pickles, and the most valuable part in the jar of pickles is the juice, okay? So that we save very carefully. And pickle juice has a lot of sodium, all right? That is very, very important. So you need chloride and sodium and potassium. And I have to tell you, it tastes so good. It tastes actually good, if you can believe it, when you're in the middle of a race. Yeah, just pickle juice. So Patrick says, at my work, we sell pickle popsicles for famished hikers. Where do you work, Patrick? Where do you sell those goodies? Okay. Mm-hmm. So the sodium in pickle juice is actually very beneficial. It helps to move the liquids, the fluids, and the nutrients around. So you actually need that. Patrick says that he works in Devil's Lake, Wisconsin. Okay, Devil's Lake, Wisconsin. All right. Connor and Jen seem to also like pickle juice. Excellent. So, yeah, so I have also, in my experience as a runner, hit the wall a couple of times. And I tell you, you really don't hit a wall, but it actually feels like you are hitting a wall, okay? It feels
It's
awful.
like the point that you can't go on anymore, kind of like?
Yes. Yes. It feels like death is right there in the next step, and you cannot take it anymore. It's an awful feeling. You really feel disoriented, and you feel like your whole body is shutting down, because it is shutting down. You know, and even though you want to continue running or moving, you can't. Okay. So have any of you ever experienced that? Have you ever done any long distance or endurance event
I have.
where you felt that? Go ahead. Tell us how you felt.
So it was at my school. We were having like kind of like a mini marathon for our school, and we had to go like all around. And if I wanted to win, so I had to go fast. But I hadn't been like training myself for it, and I hadn't really like stretched before. So after I went around like about twice around the track, I couldn't do it anymore, and I had to just jog slowly, and I was losing. And it just felt terrible. I was on fire, all my muscles.
Yes. So how long was it until you felt that? How long have you been running until you felt that way?
True.
I couldn't catch that.
Probably just.
Oh, it cut off. It says probably just, and I couldn't get it. You can write it down in the question board. Let me unmute Liberty. Liberty also says that she has felt, hitting the wall. Liberty, your mic is open. Tell us about. So Maria says that she felt it at about 20 minutes to half an hour. So I don't know, Maria, if that was a case of hitting the wall, okay, or going anaerobic, all right? Because of the length of time, hitting the wall doesn't happen until a few hours, actually, of exercise. So probably what you had, okay. Oh, so Liberty says that her mic is not working, so I'll mute her. So, and she says that it was on a 5K. So it could have been that you both went anaerobic. That means, again, like we were talking in the last lesson, where you were pushing harder, you know, that you could breathe, and so going into fermentation instead of cellular respiration, all right? So it is actually a different feeling, really. Hitting the wall is not so much that hurts, it is more like, you know, you actually, your body shuts down, okay? So it is more of that feeling. So I think that probably if it was, you know, like in a 5K, about 20 minutes, half hour, it could have been that you experience the same reaction that the triathlete guys experience when they run out, you know, and remember how, imagine these guys were going for the win, okay? And the British guy could not go faster than the Spanish. And at some point, did you see when the Spanish guy passed him that he just couldn't keep up, couldn't keep going, all right? So that was the case of going into anaerobic fermentation. So that was probably the case, all right, in here. Maria says, does it depend for different ages? I don't think so. Now, it's very rare for young kids to hit the wall because usually younger kids don't ever exercise that long, all right, to get the response of hitting the wall, okay? So that is, yeah, I have experienced both, you know, and so I can tell you there is kind of a difference in that. Okay, what do you do to stop it? It's actually very simple. You stop, you eat something, you let your body, you know, replenish some carbohydrates and nutrients, and then you can continue. So, for example, one time I was in a 50-mile race, and I hit the wall at mile 42. Mile 42. So I had only 8 more miles to go, and I just fell down onto the ground. Okay, couldn't move any longer. I just fell down, lay down on the ground. My family came. They were pacing me and being my crew. And I went to the car. My wife gave me some soup, some chicken noodle soup and everything. And in about 20 minutes, I felt good as new. Okay, I could have continued running for another 3 hours, you know. So you can actually recover from that. Okay. So Maria, are you still here with us? If you unmute your mic, excellent.
Yes.
Thank you. Okay. So were you able to read some about here the Terra Nova expedition and the difference between these two expeditions of the Robert Scott and Amundsen?
Well, I read the small paragraph about it, but I didn't see the comparison expedition.
So what happened? What do you know that happened in this expedition?
Well, there was a team, for a Norwegian team, that was led by a man named Roald Amundsen, and he was doing this race, but he found a problem that in the expedition that ultimately that they died because of it was he decided to send his dogs with a supply party, but he continued on while pushing the sled on skis. That
was the Scott expedition that did that.
Yeah, and they had, because of that, they had a poor diet that caused their bodies to consume that protein that was for energy production, and which led to a lot of muscle loss and less capacity to move forward and on, so they weren't able to finish the race.
Yeah. So this is what happened. This is a very interesting thing. There was in this year, so this was at the beginning of the 1900s. It was a multi-year expedition. They basically took a couple of years to get prepared. They had to lay depots with supplies of food to catch at later times. Okay. And this was during 1910 to 1913. And the thing was to see who who would be the first person to reach the South Pole. No one had been to the South Pole yet. And so there were these two expeditions. One was a British expedition commanded by Sir Robert Scott, and the other one was a Norwegian expedition commanded by Roald Amundsen. Okay? Amundsen had very well-trained people that they were good skiers, okay, cross-country skiers. One of the people in his expedition was actually a champion skier from Norway, and they used dogs to push the sled, okay? So the dogs have a lot of pushing capacity. And Amundsen was able to reach the South Pole here. I don't know if you can read that. It's December 14, 1911, okay? The Scott expedition, they did kind of similar things, but the problem was that when Scott reached this point, he sent the dogs back with the supply team to lay the depots of supply for the trip back. And his team, only 5 people, continued the trip on skis, all right? But they were really on a very poor diet now, okay? So they didn't have enough energy. Imagine they had to push themselves and their supplies for the trip, and they reached the South Pole on January 17. So 33 days after Amundsen. So they lost the race to the South Pole. The problem was that now they needed to get back, okay? The Amundsen team was able to get back with no problem. They still had dogs, they still had their supplies and everything, and they were okay, all right? The Scott expedition started suffering tremendously on the way back, and the problem was that because they were exercising so much, now the body was starting to use protein in order to produce energy. But what do you need the protein for? What do we build proteins for?
For energy?
Not for energy, okay? So proteins are, remember the amino acids, okay? The chains of amino acids, they build proteins. Okay, Connor says muscles. Yeah, so the muscle fibers are made out of proteins. Okay, so if your body starts consuming your storage of muscle, then you are losing the capability to actually move. Okay. Remember here in the video when we say that the fats are very good because they have no functional role. Well, proteins have a huge functional role. They do everything, you know, especially when you exercise, they are your muscle. So if the body starts eating at the muscle in order to give energy for the brain, okay, is going to get harder and harder to move. And that was what the Scott expedition was finding. And finally, you know, one person died here on the return trip, then another person died here, and then the final 3 in the expedition, Scott, Wilson, and Bowers, died on March 30th. So this is already getting really cold, and they died at this point. They were found, their bodies were found 6 months, 7 months later during the next spring. Okay, so that was a case where the body was starting to use protein for energy production. Not a good thing, not a good thing. Okay, so it can use protein for energy production, that is not what you want to do, okay? So that is a big problem, all right? And that happens when people starve, all right? Whether it's in a case like this, okay, or, you know, when they have an eating disorder or something like that, the body starts using their stores of fat, and when that is gone, then they start using protein, okay? And that is really bad. Okay. Connor says it was sad they had to shoot the dogs for food. Yes, and they actually, part of the problem is not only that they had to shoot the dogs for food. The Scott expedition sent the dogs back, okay? The Amundsen expedition kept the dogs, and they actually used the dogs for food on the way back, okay? So Amundsen actually, at one point, once they were close to the South Pole, they shot some of the dogs that they didn't need, and they buried them, and then on the way back, they unburied the bodies of the dogs and took them for food, all right? It's sad, but it's just necessary, you know? So very, very important in order to maintain your balanced diet, okay? So Joseph, you, well, you would do anything to keep going. Okay. Yeah, Emmeline is singing the circle of life. Okay. Yeah, this place is a freezer. This is the world's freezer. So let's see, Chas, would you like to open your microphone and tell us something about here, this academic concept? Okay.
Can you hear me?
Yes.
Okay. While I was reading this, I was noticing it was usually all about all the cycle of our cellular, like our cycle of our life through the cells. It also has the transport chain and all of the fat, and showing how they worked through the cycle. And
okay.
Yeah.
So here we say that in the last lessons we learned about different processes for the cell to obtain energy. Okay.
Okay.
And we look at these three processes. All right. So what can you tell me about, for example, cellular respiration? You remember anything on that one?
Can't quite remember.
Okay, all right. Do you remember something about fermentation?
I think I do.
What do you remember?
Fermentation is helps power our cells, or
yeah, all these are processes to obtain energy. Okay. All right. So the point here is that there are different pathways, different processes for the body to obtain energy. Cellular respiration starts with glucose, and we end up, you know, with carbon dioxide, water, and ATP. Okay.
Okay.
Fermentation also starts with glucose and ends up with lactic acid and ATP, less ATP than respiration. or the alcohol fermentation, you end up with alcohol and carbon dioxide and ATP. And then in the fatty acid metabolism, what do you start with? This is what we have looked today. Okay. So you start with fatty acids, okay, you know, these chains of carbon, all right, and you end up with carbon dioxide and also ATP, a lot of ATP. So there's, you know, 3 different metabolic pathways of that, all right, and there are thousands of these metabolic pathways in the body, really, lots of them, okay? And so here we have just a little graph showing a few of the many, many metabolic pathways that are that the body has, okay? Every single thing that the body does is one of these metabolic pathways, okay? So, Nathan, would you like to share with us some things that you've learned here about this gospel principle?
Sure. So I'm doing gospel principle 1, correct?
Mm-hmm.
Okay.
Yes.
So it's keeping the word of wisdom is a great blessing of freedom, health, and self-government. Last year for Doctrine and Covenants in seminary, we studied the Doctrine and Covenants and gospel. One of the scripture masters was D&C 9 through 11, I think it was. Like the scripture master. It's a scripture mastery. How those who keep the word of wisdom will receive help to the navel and marrow in the bones. And then that shows that if we, it says always 18 through 21. And also, and it also says that if we do it, it won't just help our physical body, it will help us mentally. In verse 19, it's trying to find wisdom and great treasures of knowledge, even hidden treasures. So if we keep the word of wisdom, it will also help us with our mind, notice our body, which says, and shall run and not be weary, and shall walk and not faint. So in that scripture it says that it also helps our physical body. Then in 21 I found it interesting when it says, and I the Lord give unto them a promise that the destroying angels shall pass by them as the children of Israel and not slay them. And I was kind of wondering what that meant. Then I realized that it means that in the last day, all those who rejected Christ and didn't follow his teachings, the destroying angel will come slay them again. But if we keep the word of wisdom, then it will pass by us like it did Moses and the children of Israel.
Absolutely. Excellent. Good. Yeah. Anna says, keeping the word of wisdom helps us to develop self-control and conquer the natural man. Okay. How does keeping the the word of wisdom help us to develop self-control? What do you think, Nathan?
What was the question? It's hard to hear.
Oh, yes, no problem. How does keeping the word of wisdom help us to develop self-control?
if we have a foundation on what we believe on, and if we have a sure foundation, then when we are tempted by our friends, then we won't be easily persuasive. But if we are weary on it, saying, well, this is not my rule, this is God's rule, so I'm not sure if I want to keep it. And then when you get tempted by your friends, then you'll be more easily to give in.
That's right, yeah. I remember growing up in Argentina, I had, of course, many friends that didn't keep the word of wisdom. They were certainly not members of the church. And they always said, wow, your church is very restrictive. You are not free to do a lot of things. Like you are not free to smoke, you are not free to drink. And one time when they were telling me that, I told them, I said, actually, I am free. I still can choose. I still choose whether I want to smoke or not. Okay, I can choose any time. All right, I just choose not to do it, but I still am free. You, on the other hand, and I was, talking to people that were addicted to tobacco or alcohol, I said, sadly, you are not free. You cannot stop smoking or drinking. So who is more free? Does that make sense?
Yeah. Maybe you're both free to choose, but when it comes to the end of the world, then for judgment, you'll be more free because you listen.
That's right. Yeah. Okay. Yeah. So that is very, very good. Okay. Liberty says fasting doesn't have any negative consequences because it's only for one day out of a month, right? I've heard some people say that it's even good for you, and that is true. So fasting is actually a good way for our bodies to replenish the glycogen stores, okay, to use them up and replenish them, and also for our bodies to trigger the response to do fatty acid metabolism, to metabolize fatty acids. It's just for one day, so we certainly don't go into anything even close to starvation. So it's actually a good thing. It's a very good practice. And also it develops a lot of discipline and control. Okay. Yeah. Emmeline says, simple, consistent, good habits lead to a life full of bountiful blessings. Stay on the Lord's side and you will win every time. A quote by Elder Scott. Thank you, Emmeline. Thank you. Melissa says, some people can't fast, though. Yes, I think that there are some people that find it either very difficult or they could get a very bad response of hypoglycemia. Okay, and so you have to, like we mentioned, in the previous lesson, not run faster than you can. Okay, everything needs to be done with wisdom. Okay, in order. Liberty says pregnant women shouldn't fast, right? That is also true, because when a woman is expecting, a lot of the energy, okay, and now we know what energy means, the production of ATP goes to the baby that is being developed, all right? And so you don't want for the baby to have any adverse reaction within the mother. and have plenty of glucose and oxygen in order to continue developing correctly. Okay. Nathan, is there anything else that you would like to add? Mm-hmm. Okay.
Yeah. I just wanted to share that I know that if we do our best to not give in to peer pressure when your friends are not probably the best influences, offer you drugs or stuff that are against the world wisdom, that if you will make a conscious decision before, like right now, that you will not give in, that you will be more stronger than if you make it right as they ask you, because if you already have an idea in your mind that you're not going to give in, then it's going to be very hard for them to persuade you. But if you decide right as they ask you, then it's going to be pretty easy for them to persuade you.
That's right. Absolutely right. Okay. So we know now more reasons of why keeping the word of wisdom is important. Okay. Now I hope that you have learned some of the pathways, these metabolic pathways, on how these chemicals are processed, and why is it important to have a good, healthy diet. Okay. And like you said, Nathan, if you decide now, it is a lot easier. Okay. So I never have a big problem with that, and it was it has been a great blessing throughout my life. So, Camden, sorry we ran out of time, and Natasha, would you like to dismiss us with a word of prayer, please? Okay.
Sure. Heavenly Father, I'm thankful for this day and that it's in class today. Please help everyone that couldn't be in class today get to class next week. Please help us to use what we've learned today in our lives and help us to learn some more. In the name of Jesus Christ, amen.
Amen. Thank you very, very much. Thank you. I apologize that the class went a little longer, but I appreciate your staying